Hello, so today I'm going to be solving for the vertical and horizontal components for each member along this truss. And I'll be doing so using the accelerated method of joints. So as you can see, there's an external force over here at 15 kN, another external force 30 kN, one more at 15 kN. And then the vertical distance is a grand total of 36 meters, and the horizontal distance is 5 meters. And in this problem, there is a hinge at this joint right here and a roller at this point. So what I'm going to do first is to determine the zero force members. And so over here, I can determine that the vertical component here will be 0, as if I look at this joint, there is only one vertical component here. And for it to balance out to 0, this must also equal to 0. So I'll put 0 here and 0 here. And then there's another zero force member here because there's no arrow, there's no force to the left. So for the x-axis to go to 0, this member must also equal to 0. So this is 0. Okay, so I'm going to return back to this joint here, and we'll look at the horizontal components. So for each joint, what we're going to try to do is to make sure that the x and the y-axis, all of the forces add up to 0. And so what would be needed for this joint to reach 0 along the x-axis there would need to be a horizontal component at 15 kN that goes opposite of this external force right here. And along this beam, to balance out this 15 kilonewtons, there would be another force going this way with the same value. Okay, so at this point, this is all done. We have the vertical and horizontal components for this joint right here. So I'm going to move on to this joint. There are two, if you break this up into a vertical and horizontal components, like so, there are two unknown vertical forces here. So I'm not going to look at those for now. However, there is one horizontal force here. And for this joint to balance out to 0, it has to be 15, but in the opposite direction. So then just redraw the arrow. It'd be 15 over here. And then the vertical and the horizontal components have to be pointing towards the beam, like this. So that's why I drew the vertical arrow downwards. So now I have to get the vertical component here. And the way I would do it is using a ratio. And so the easiest way I remember how to get this number is that I would take 15 here, for example, and then I multiply it by, so the component I need is vertical, so I look at the vertical distance along this entire beam here. And as you can see, it basically goes down like this. So it will go down a distance of 12 meters. It goes horizontally like this. So the horizontal distance of the member would be 5 meters. And so the way that I would remember how to do this is that the direction of the distance should be parallel to the direction of the force. So because I'm looking for a vertical member, the number that's going to go on top is going to be the vertical distance. So in this case, it would be 12 meters. And then on the bottom, it would be 5 meters. And when I do the math, I would get 36 meters. And That's what I get over here. There has to be an opposite reaction to this down here. So it would be the same numbers as we have up here because it's the same member, but it'd be in the opposite direction. So it'd be 36 again here, going up this time instead of going down, and then it'd be 15. Going from the left instead of the right this time. And then if you want to go back to here, we have a vertical component now. So in order for this joint to balance out to 0 in a vertical direction, we would have to have 36 going up. And then to balance out this member here, we have 36 going down because it's opposite in direction to the beam up here. So going along here, we do the same thing. And because there's no other vertical forces except for this joint to go to 0, the opposing force would have to be 36 going up. That way, these two numbers add up to equal 0. And then it's basically the same thing down here with what we did up here. Okay, so if I try to do this joint right now, there are too many unknowns. I don't know what the vertical force is. Or sorry, horizontal component. I don't know the vertical component here. And it's the same for here, here, and then for this member here. And because there is a force, external force acting on this joint here, this member is not a zero force member. So what I can do is find the reactions at this joint right here. So if you notice, I can get the horizontal component here because I have this horizontal component, which is 15 going to the left. I have this external force, which is 30 kilonewtons to the left. And then this horizontal distance, we can basically ignore it because it's a zero force member. So for this joint to go to 0 at the horizontal distance, it would have to be 30 plus 15 kN going to the right. So that would be 45 kN. And now that we have a horizontal component along this member, I can find a vertical component. And this is going up because both of these arrows should be facing towards the beam or the member. And so basically, I'll do the same thing that I did to find 36 the first time, which is that the given component or the component that I have is 45, and I'm looking for a vertical component. So on top is going to be the vertical distance of the member, and on the bottom is going to be the horizontal distance for the member. And as you can see, it's basically the same, or exactly the same, as with the previous member, diagonal member. So on top would be 12 meters, and on the bottom would be 5 meters. So after getting that, I would get 108 meters. And by the way, so what if I was given 108 instead of 45, and I need to find the horizontal component? So what I would do is basically the same thing, but instead of the vertical distance being on top, because I'm looking for a horizontal component. Let me change to red actually, so it's easier to see. Because I'm looking for a horizontal component, I will have the horizontal distance of the member on top, and then the vertical distance would be on the bottom. So I will have 5 because that's the horizontal distance, and 12 right here because it's a vertical. And if I do the math, so it's 9. So the horizontal component, if I use 108, is 45. So it works both ways. Okay, so there has to be an equal but opposite reaction on both sides of the members. So down here, I would have 45 kN going to the left and 108 kN going down. I have two options that opened up. I can go to this joint and find the members, start to find the members here, or I can find the vertical component here. And since we're pretty much done with this, why not let's just finish this off. For this joint to go to 0 at the vertical, for the vertical components. So this is 0 force members, so we basically can ignore this. But we have a force going up at this joint at 108. That was a value of 108 kN, and then another one at this member, which is 36 kN. So for it to go to 0, I would need a force right over here. The force would be 36 plus 108 going in the opposite direction. And that total is 144 kN. Here's the opposite reaction. And we're done with, so right now we're done with this joint, this joint, this joint, and this joint. Let's go to here, since this is simpler. So because at this joint, there is no other vertical components that I have to consider, except for 144 here. For the vertical component at this joint to go to 0, I would have 144 going in the opposite direction, which is down. So I have this. And for the vertical components, I have a force of 15 kN external force going to the left, so I would need to have 15 kN going to the right. And this is the opposite reaction for the member. Okay, to be consistent with the example that I'm using right now, I mistakenly put 15 kN here when it should be 30 kN. I mean, it doesn't, you should get to the right answer regardless of the number because the method is correct. Just to be consistent with the class example that I am using, I'm going to change this number to 30 kN instead. So I'll change this external force down here to 30 kN. So right here along this beam, the force would be 30 kN instead of 15 kN. Okay, and we're now back in business. So let's go to this member right here. This is already completed, so we're done with this. So right now we have two unknowns for the vertical and horizontal components, like so. However, there's only one unknown, which is down here for the horizontal components. So two vertical unknowns and one horizontal unknown. So I can get the vertical component here since I can find the vertical component here at this joint. So for this joint to go to 0 at the horizontal components, there is 45 kN going to the left and 30 kN going to the left. So for it to go to 0, you add them up and put them in the opposite direction. And 30 plus 45 is 75. So the force right here would be 75. To get this vertical component, what I'm going to do is basically what I did before. So I would use 75 times 12 divided by 5. And let's see. That should add up to, or that should multiply and come out to 180. So this member right here is 180 kN. So the opposite but equal reactions components are here. 75 going to the left and 180 going up instead of down. And so let's finish off this joint right here. So now that we have all of we only have one unknown vertical component. For this joint to go to 0 in the y direction, vertical direction, we have 108 plus 36 plus 180. And adding that up and putting it in the opposite direction for it to go 0, it would be a total of 324 kN. Like so. Okay, so that joint is done and that joint is done, which leaves, so what's left is the joint on the, or the member on the bottom and the two reactions. Because there's no horizontal component here, I would just redraw this. I could redraw this as one vertical component. Over here, it would be one vertical and one horizontal component because it's a hinge. So at this joint on the bottom right, for it to go to 0, because there's no other horizontal component except for 75 going to the left, for this member, it would be 75 kN going to the right. This is the opposite component for this member. Okay, and for the same member, or the same joint here, I can find a vertical component, or not the vertical component, the vertical reaction at this joint. And what vertical forces do we have? We have 180 going up and 144 going up. So I have to redraw this if I want it to be accurate. Oops. Technically, the arrow should be pointing downwards. So it would be 80 plus 144. That should be 324 going down. Or if you wanted to keep the sign, if you want to keep the arrow going up, it would be negative 324. But because throughout this entire process, we kept the numbers positive, I decided to change the arrow, so this number will remain positive. Okay, so to find the other two reactions, it's basically the same. So let me redraw the arrow for the horizontal component on the bottom left. And for it to go to 0, it would just be 75 going to the right. And for it to go, to find this, the only other vertical component at this joint is 324. So this reaction has to be 324 going up, since this is going down. And that is all of the vertical and horizontal components for this truss. So you might be wondering, how would I find the force in these diagonal members? Like, for example, let's call this, then change to green. Let's call this member A, or sorry, this joint A and this joint here B. So we're going to be trying to find the force in this member here. So for these diagonal members that are not just going straight across or straight up and down, we're going to use a squared plus b squared equals c squared for it. So how that'll look like is, let's call this force AB. That would be equal, it'd be force AB squared equal to the horizontal force of force AB, which is 15 kN squared, plus the vertical, which is 36 squared. And because it's going to be squared, if you decide to put a negative here, it'll still become positive. So you just take the square root of that, and then the force would be 39 kilonewtons. So basically, whenever you have a diagonal member, you would just calculate it like this. And then for the horizontal and vertical members, you already given these, or you found these values already. And what these arrows do for the vertical and horizontal components, they just tell you whether or not the member is in tension or compression. So these two arrows are pointing in, for example, right here. they're pointing in towards each other. And the easy trick to remember is that to tell whether it's in compression or tension, it's in the opposite direction. So because they're pointing in together, the opposite would be tension, because the opposite of them pointing in will be pointing out. And that's basically how you find the members in a truss using the accelerated truss method. Hope this helps.